find the zeros of the function algebraically, one thing we need to know about the term zeros, these show up as x-intercepts on the graph. And if you think about what an x-intercept is, if you look back to problem number 1 of this summer packet, x-intercepts happen when y is equal to 0. Another name for y that we use when we're talking about functions is f of x. F of x is sort of another name for y. So I could write this out in front. And so we're trying to figure out what x values would make y equal to 0. Therefore, they would be an x-intercept. So let's think about setting this fraction equal to 0. And the only way that a fraction could equal 0 is if the numerator is 0. It doesn't matter what the denominator is, because if you had 0 over 1, it's equal to 0. 0 over 2, 0 over 5, 0 divided by 10, 0 divided by anything will always equal 0. So we don't need to look any further at the denominator. From this point forward, we just need to focus on solving this top part. What values of x would make the numerator equal to 0? So I'm going to rewrite that equation off to the side, and it looks like we can do some factoring here. So let's take out a common factor of x, and then we can factor one step further. This is a difference of squares. Let's factor it into x plus 6 times x minus 6. And if we think about setting each one of these factors equal to 0 and solving for x, we would get x equals 0. For this one, it would be x equals negative 6, and this would be x equals positive 6. So that is going to be answer choice A. The most common mistake I see on this problem is that students will also think about what do I have to do to get the denominator equal to 0, which is why you'll see these two answer choices involve a 1/3, because that would be the result of setting our denominator to 0. But what you need to remember is that the denominator doesn't matter.